Hello, hello. Welcome. I am live and looking for myself. Hmm. So, still looking. If you're here, hello. Nice. Found myself. Hello, Aspen, Michael, and Andre. Welcome, welcome, welcome. This is maybe the last stream before the AP tests. Kind of gauge interest after this. I've done 25 FRQs since we last met. Dang. That's good. So that's like 5 AP tests worth. Like real AP tests, not this year's AP tests. It's like 8 this year's AP tests. Hello, Chelsea. Welcome. I was going to go over the questions off that last homework piece that weren't on any of the mock tests, which was 2 and 4. That's my plan. And then I have a couple more free responses to peek at today. Imagine being that dedicated. Yeah. One thing I can say is AP tests are like ultra worth it to be prepared for. Like crazy worth it. Especially if you have to pay for your own college, like I did. Because you can get 10 credits, and I paid $2,000 a credit my senior year because I couldn't afford to go full time. It's crazy, crazy, crazy how value it is to do well on AP tests. Totally nuts. Alright, I think we have enough people here to probably get started. Weirdly, I'm starting with going over things today, kind of changing it up a bit. So, this was one of the questions off the homework, the number 2. If you're curious about the other ones, I posted solution guides on Teams, and I'll show you that in a sec. And also, my other FRQ going over videos have all of the other questions except the area volume one on here. So, yeah, lots of resources available. All right. So we have 2 equations, A and B. A, they give us an equation for. B is more of abstraction there. They intersect at this point that they tell us, 2.416. And it says, during the time interval 0 to k hours, water flows into tank B at a constant rate. So that's kind of nice. It has a constant rate. What is the difference between the amount of water in tank A and the amount of water in tank B at time t equals k? So it says it meets twice, once at 2.416 here, and once at this value we don't know, which is what they're calling k. And B is flat there, so that stays consistent with what they're describing. Oh, hello to all the new people. Hello, Rose. Hello, Bryn. Hello, Nick. Hello, Kaido. And dang it, I can never remember who Eggroll is. uh, okay. Anyways. Oh, whoops, I skipped A. How much water will be in tank A at time t equals 4.5? That makes it way easier. Oh, yeah, Ethan. Right. So how much water flows into tank A is an integral from 0 to 4.5 of A of t dt. And that's all you have to do for that one. So you can just put that in a calculator, and if you do... Oh, did I open up the wrong scoring guidelines? Good job. I can fix this. Can I? Oh, yeah. I can definitely fix this. Cool. It's 66.532 liters of water. And sorry, Ethan. Welcome, Dylan. Welcome, Elizabeth. Welcome, Tim. All right, for B, it says water flows in for K amount of, what is our time unit? Hours, K hours. So the amount of water that flows into tank B is 20.5 times K, because it's like linear, it has a constant rate. The amount of water that flows into A is the integral from 0 to K of A of t dt. And so really we just got to figure out where these two pieces align here. So where their values are equal. And that's the play. Now, the nice part is you basically just know that the you can cheat this by taking the derivative of both of these things with respect to that k piece, and you know the A equation, so the acceleration, the flow rate equation for tank B is 20.5, and you can just set that equal to the flow rate equation for B there, and you can figure out that K happens at 0.892. However, this is an intermediate answer, so we should go for more decimals here. And 0.892040 is our decimal piece there. So literally all I did on my calculator, if you're curious, is set y equal to 20.5 and look where it intersects the graph. And you can tell from looking at it here that it is just 20.5. So there's no magic to that part of the question. And then it says we still have to figure out what's the difference. So we got to now plug this k back into this original equation as a bound and just times 20.5. And if you do the 20.5 side, you get 18.2868 or so. And then you just figure out where the integral equals that value. Oh man, it is really hot up here, and when I'm really warm, I struggle a lot. Do you recommend using a Word document or handwriting for the AP test? I recommend handwriting. Where is this problem from? This problem's from the homework. There are some repeated questions, absolutely, if you did both mock tests. There were only 3 original questions on here, and one of them was one we don't know how to do. Anyways, to continue rolling on this question here, if you plug into A, you should have gotten, where is it? 10 points. Oh, no, I goofed. You get like 8 point something. If you subtract the integral from 0 to 0.892040 of A of t dt from this 18.268 whatever blah, you get 10.599, and that's in liters. So that's the difference between the two tanks. So literally all you have to do for that one, if I wipe this all out, is figure out where they meet. So figure out where 20.5 equals A of t, and you figure out that k value. And then all you do is do 20.5 times that k value, and do the integral from 0 to k of A of t dt, and just see what the difference between those is. And that was 10.599. All right, for our next part, the area of the region bounded by the graphs of A of t and B of t from k to 2.416 is 14.470. How much water is in tank B at time t equals 2.416? Okay, so this 2.416 is just a really ridiculous value here. Basically, whoops. We can use stuff from our previous question to go about solving this, because we already know that, oh gosh, what am I doing? I'm goofing. Here we go. The integral from 0 to k of b of t was just like that 18 thing. Yeah, 18.26 or 286. This was from the previous question. We had already done this. K is like the 0.89 thing, and 20.5 times that 0.89 thing gives you 18.286 826. So you get this mess. Then what you need to do is find the integral from k to 2.416. And this is kind of the trickier piece. So for this, we should go back to the graph. So if we go back to the graph, we can see which function is on top from k to 2.416. And what we have is that a is on top. And so a minus b would give us the spot in between those two pieces there. So what I want is to figure out what b is. So I want to figure out this crap, because that's how much water will be in tank B from 0 to 2.416. And since I know a minus b is the area that they gave us, which is 14.470, all I'm going to do is figure out the area of a and subtract 14.470. So all I'm going to do for c is integrate from 2.416, or sorry, k to 2.416. K comes first. So I'm going to integrate from k to 2.416 of a of t. And I'm going to subtract 14.470. And remember, k is a value we know. It's 0.892. So all we're going to do is plug this into our calculator. If you do this, you should get 30.027. And if you add this to the 18.286, the 20.5 times b, we get how much water is in the b tank. And so we just add 18.286826, this piece. And if you do this, you get either 48.314 or 48.313. That's a pretty hard at bat because there's a lot of moving pieces there. Couldn't k be any time? It can't be because of the stuff they give us in the question. So to loop back, it says that b is going at a constant rate of 20.5, so it's flat from here to here. So I know k has to be the time at which a of t goes through 20.5. And so it has to specifically be that 0.89 blah, 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 blah. All right. Our last one says, during the interval 2.7 to 4.5, the rate at which water flows into tank B is modeled by this equation. So we actually get an equation for B. Is the difference between B and A increasing or decreasing at time 3.5? So we're looking for is the gap between the curves growing or shrinking at 3.5? And if we try to just eyeball this from the graph, which maybe is a good place to start, it's kind of hard to tell. My guess is that it's shrinking there. So that's where I'd already lead with that idea. Now I have to prove this with the with the math in the question, but I can tell already that I think I'm shrinking here. Like the distance between the curves is getting smaller. So let's see. So we get this W equation. And what we want is, so there's W of t, and there's, what's the other equation called? A of t. And they're both messes of stuff. They're big, complicated equations. But since what we want is where the rate between these is changing, what we want is actually w prime of t minus a prime of t. If I did w of t minus a prime a of t, all I would get is the difference between the two curves, so the difference between their rates. But I want the change of their rates to see if that is increasing or decreasing. So all I do is on my calculator, I just do, d over dx of blah evaluated at 3.5 minus d over dx of blah evaluated at 3.5. And you can do this by doing menu 1 and numerical derivative at a point. If you don't have a calculator, the alternative play here is to actually, in Desmos, you can just graph the derivative of the function. Like if you type in w of t, well, if you just type in this, w of t equals 21 minus 30t over t minus 8 squared, what you can do then is you can say like z of t equals d over dx, or d over dt in this case, since it's a t function, of w. And then it will graph the derivative, and then you can just trace to 3.5, or you can say, give me z of 3.5. So it's a little different depending on whether or not you're using Desmos or your graphing calculator, how you go about doing that. Menu 4? Oh, my bad. Yeah, right. Menu calculus and then 1. Numerical derivative at a point's the first thing in calculus. For that. And if you subtract these two rates of rates for this, you should get that it is decreasing. So that fits with my hypothesis from the beginning. So, I mean, feel free to use, like, the idiot check. So decreasing, heck yes, because if you subtract those, it's negative. However, we could figure that out just by looking at this. Like, is the gap between these two graphs growing or shrinking? And the answer is it's shrinking. They're getting closer and closer together after this 3.5 point. So we were able to ballpark that just by looking. So sorry, I talked a lot through this, but hopefully I was kind of blazing through AP questions, and I wanted to slow down a little bit and talk through, especially that one, because that one was pretty involved. All right. Do you know how to fix errors that... Okay, Akarsh, your calculator can't do algebra. You're trying to make your calculator do algebra. So this is a problem you've had quite a bit. And other people have too. You can't do integrals that aren't definite on a non-cast calculator. So you have to put bounds or it will not work. You have to have your dx or whatever match the variable on the inside. So that's another spot where a lot of people go wrong. And the last piece is you can't just, on a calculator, you can't just type this into a scratch pad. It can't do this. It can do numerical derivative at a point, so if you put the little line afterwards and say evaluated at 2, it can tell you the answer's 4. It can't tell you the answer's 4 with this. But what it can do is if you graph this, so if you do this in the graph instead of the scratch pad, and do this as f1 of x equals this garbage, then it will graph the derivative of 4x, which is just a straight line at 4. So your graphing calculator can graph things that are derivatives, but it can't spit out an equation that is the derivative, unless you have a CAS. So I hope that answers your questions. I believe those are the main errors people make when they think their calculator won't work. I was talking about when you want to set f of x equal to a function. Oh yeah, that f of x thing was almost entirely talking about Desmos. So on a calculator, when you want to set f of x equal to something, you go into your graph, and you make f1 of x equal to whatever you want. So like x squared. And then if you go back to your scratch pad, now f1 of x, which you can get with the var button, will always be x squared. And you can do like f1 of 5. And it will spit out, 25. And so that's that's the play. You can't, like, in your scratch pad say f of x equals x squared, because it defines functions as f1 of x, f2 of x, f3 of x, which are all artifacts in the graph. So if you just graph everything from the beginning and use those graphed function names, you shouldn't have any problems and no errors. Okay, so I want to move on to question 4. I'll try to answer any questions that come up if they come up. But this function is more my wheelhouse. This is the no calculator kind, although on the actual AP test you get a calculator for this, so there's no faults or badness here. All right, so anyways, we have this table. It tells us that it's continuous, and its second derivative is continuous, so it's twice differentiable. This literally just means twice differentiable. They just found a different way to say it. And it says, use a midpoint sum with 3 subintervals of equal length. What it means by equal length is we're going from 0 to 6. And if I split this into 3, 6 divided by 3 is each of my rectangles is going to be 2 wide. So I'm going to be going from 0 to 2, so 1 is the midpoint. I'm going to be going from 2 to 4, so 3 is the midpoint. And I'm going to be going from 4 to 6, so 5 is the midpoint. Now, the midpoint values, the f prime of x at each of those midpoint values, is the value I am going to use for the height of each of my rectangles. So my first rectangle is 2 wide. They're all 2 wide here. 0 to 2, 2 to 4, 4 to 6. And I do 2 times that midpoint value plus 2 times the other midpoint value plus 2 times the last endpoint value. And we just add all these dudes together, and we get, what, 8.6 plus 11.6, which is 20.2. Once we're done, okay, so when AP testing is done, we're going to talk about area and volume, but before then, we're going to be chilling. You're going to get some time off from listening to my voice, unless you want to watch my meme stream on Thursday. All right, next one. Determine whether the actual value of f of 6 could be 70. Why did I take my graph off the page? That was really dumb. All right. So could f of 6 be 70 is what this is saying. So first of all, we know the initial condition is 20. So 20 is our starting point. And then these are the slopes at all these different points. So they're all the possible slope values that could change us across each of those points. So if I think back to my Riemann sum from here, I got 20.2 for this. If I add 20.2 to 20, that's omega trash. That does not reach 70 for my estimated value. But midpoint sum is not the best way to test if it could reach 70. Our play here is to actually use the max sums. So pick the biggest value and use that as the value on the interval, because that will give us a better indication of whether or not it gets crazy big or anything like that. Another play is actually to say that, hey, look, the slope is between 0 and 7. So 7 is the max it can be for any value. If I just assume that the slope is 7 for the entire interval, then the integral would be 7 times 6. 7 times 6 is 48. Wait, did I do 42? Yikes, that was really fantastic math. Is 42. If I add that to 20, I get 62. So I can't even reach 70, even if I'm the max slope for the entire thing. So yeah, for multiple reasons, B is trash. So that was using the absolute max value possible there. And yes, f of 0 is 20. Oh, did I forget that? Oh, yeah, I forgot to approximate the value. I found the Riemann sum, but you need to add 20 to it, so it's 40.2. Might be... Okay, so for C, it says evaluate the integral from 2 to 4 of the second derivative. This is actually pretty gravy because the integral of the second derivative is the first derivative. And if you evaluate it 2 and 4, all it is f prime of 4 minus f prime of 2. So this is just this value minus this value. 1.7 minus 2 is negative 0.3. And we good. All right, our last one. These questions are often L'Hopital's rule, so let's see if this one's L'Hopital's rule. So, f of 0 is 20. E to the 0 is 1, so it's 20 minus 20 on top. And if I plug 0 into f, I get 20 again, so I get 10 on the bottom minus 10. Oh, for sure enough, this is L'Hopital's rule. So if I take the derivative of top and bottom, I get f prime of x minus 20e to the x, because the derivative of 20e to the x is 20e to the x. And the bottom's derivative is 0.5 f prime of x, and 10's derivative is 0. And so now if we just plug in all these values, which we do know all these, f prime of 0 is 4. It's still minus 20, because 0 plugged in still gives us a 1 for e to the x. And half of 4 is 2, that's our bottom, and so this is negative 16 divided by 2, or negative 8. And that's it. For B, can we draw the graph in the rectangles and show midpoints or underestimates for increasing graphs? No, because the graph isn't always increasing. It's why the way Daikun talked about it, it's why I was talking about you have to use the maximum value. So the maximum possible value. To say whether or not it could ever reach that. Because it's possible the derivative graph looks like some sort of jank garbage like this. It goes through 0, 4, 1, 3.5, 2, 2, 3, 0.8, 4, 1.7, whatever. These are some jank. This is a terrible picture of the graph. But what if the graph looks like this? Which is like super ugly and everything, but you have to assume like, hey, in the best possible case, I guess it says it never goes above 7, so I should, oh, sad panda, I got rid of all of it. But the point is, like, if you always have big values that are never bigger than 7, but you always like err high, you need to account for the fact that you could be averaging a slope of nearly 7 across the entire thing. And so you can't use a justification of the midpoint method for it. All right, that was deep and heavy. Okay, so if you have any other questions for other questions on, could you see, if the question said the graph, yes, if the question said the graph was increasing, you could say stuff like that. Like if it said it was always increasing and the values supported that, then you know way more about the slope. You know, in between two values, the slope is always in between those two. And you know your graph doesn't look like this mess of stuff. And so, yes, you get way more information if you know the graph is always increasing or always decreasing, or even if it's concave up or concave down, always. If you did the wrong questions, feel free to do the right questions. Like, no questions were wrong here. Some of them were just repeats of mock test questions, which is totally fine, which is why I want to talk about this. If I didn't go over the question you wanted, if you log into Teams, I have my solutions for the first two mock test videos. So the one last Wednesday and the one the Saturday before. And I have the entire solution guide for this homework. So, oh poop, I messed up. I'll fix that link. Dang it, really? I put the sharing link in there. That makes me sad. Well, I'll fix that link. That will be a solution problem. So I goofed, Bryn. When I said 3, 5, and 6, I meant everything but 3, 5, and 6. And in my notes, I forgot to write everything but. So I actually meant 1, 2, and 4. So I messed up last stream. I'm sorry. I fixed it afterwards when people were emailing me unhappily. You made an attempt at the area volume question. Sweet. We'll be taking a peek at that in like 2 or 3 weeks. Probably 2 weeks, maybe 3 weeks. I don't know. To try to figure those sort of questions out. It turns out they're not very hard, and we don't really have a lot left this year of material to cover, and it's going to be a pretty chill unit. Number 5 should be illegal. Which one was 5? It was at the area volume. Area volume's not scary. Don't be scared by it, especially if you're a pretty good spatial thinker. All right, I have this beautiful question that I'm going to try to make look good. I didn't do it in PowerPoint, so it's going to look a little crap, but try out these at bats. Tried disc washer method and turned out bad. A is easy, true. Yeah. So try this out. So we have this beautiful Wait, didn't we already do this question? Or did I already do this question? No, we didn't do this question. I already did this question. Haha. And yeah, seriously, it's not hard, but it's not on the AP test, so don't worry about it. Don't worry about area and volume. Dorothy and you just did this. Oh, nice. Yeah, I snagged this question off the optional practice, so some of you have probably taken a peek at this question already. So for the first one, you're finding f of 7 and f prime of 7, and for the second one, you're trying to figure out where f, which is not this graph, attains its maximum value. So please note that f is not this graph, and that this graph is labeled as g. And that f is actually is 3x plus the integral from 0 to x of g of t dt. So this is very similar to a question we did, and it's why I'm bringing it back. These graph questions are very, very likely to be on this test tomorrow. Like super duper. And holy smokes, it is so stuffy in my house. I am dying. But yeah, tell me when you're done with these two, and we'll go down and take a peek at the bottom half. / check your answer if you just did this. Wow. So again, the impetus behind these is when these problems were assigned, there was like a 30% success rate on this kind of question, where they give you a graph and then they tell you that there's another function that is the integral of that graph plus some crap, and that makes it quite a bit more involved to do. F is fine for me, but F prime is whack. F prime is actually the easier of the two. Uh, just a little hinteroonie. Alright, I'm going to start talking about these real quick here. So, first of all, f of 0 is really easy, because 0 plus the integral from 0 to 0 of anything is 0. So that's like base point value. So they didn't give us an initial condition, but by plugging in 0, we get the initial condition. It's 0. So we're going to use this like as our starting point. So from 0, I need to figure out the area of the semicircle, which is negative 1/2, because it's half of a circle, pi 3 squared. So negative 9 pi over 2. And because I'm going to 7, I'm actually adding this piece, which has an area of 3. So from 0, I go down 9 pi over 2, and I add 3. So it's 3 minus 9 pi over 2. And no worries about being late. Everything's always posted. All you missed was me going over 2 of the questions on the homework that I put on the AP test homework thing, 2 and 4. Okay, f prime of 7 is just the value of the graph at 7, kind of, because f prime of x is the derivative of 3x, which is 3, plus the integral from 0 to set. Wait, no integral. We're taking the derivative of the integral. So we're just getting g of x. So it's 3 plus g of x. G of x is 3, so it's 3 plus 3, which is 6. And so you actually definitely need both of the pieces. So I don't you need to add the 3x? Oh, psych. Yeah, totally forgot to actually. Sorry, I missed that in the first part. I needed to add 21 to this. I totally just figured out the other piece. So it's actually 24 minus 9 pi over 2. Good job, Mr. Kennedy. Okay, find the value of x in the closed interval where it attains a maximum value. So this is going to be a little hairier. But we already know some values, so that's going to be really helpful. First, we know 0, 0 is a value. Second, we know 7, 24 minus 9 pi over 2 is a value. So the other points we should figure out are like the critical points and endpoints in the graph. So like this. So the zeros and the like endpoints. So I should see what all of these are. If I go back to -4, I've gone up from -4 to 0, and the area of this shape is 4. So that means I started at -4, -4, and then went up 4, because this has a positive area, to get to 0, 0. So that's not the absolute maximum value. Oh, -4 to 3, psych. This is my cutoff. So, okay, that means I'm only testing -4, -4, 0, 0, and whatever 3 is. So I find f of 3 by doing 3 times 3 plus the integral from 0 to 3 of g of t. So the integral from 0 to 3 is half of my semicircle. So it's 9 pi over 4. So I'm actually doing 9 minus 9 pi over 4. So the question we have to ask ourselves is, have we subtracted more than 0 over 0? Like, is 9 minus 9 pi over 4 bigger or smaller than 0? So 9 minus 2.25, which is 9 over 4 pi, is actually a positive value, because pi is like 3.14 or something. If you multiply 3 by 2.25, you get 6.75. So definitely the 0.14 isn't going to push us over. And that makes this absolutely the max. Why would you test 0? It's not a critical point for f of x. You just test all of g's critical points. It's the safest play to make, because 3x doesn't have any critical points. So you should just test all of g's critical points there. That's the safe play. Otherwise, you have to take the derivative and set it equal to 0 and find the actual values for maxes and mins and that sort of garbage. So let's do that play. If you do 3 plus g of x here, and you set this equal to 0, you're looking for where g of x equals -3 here. And that garbage value there, that is not a maximum because that's definitely a negative value. So that's where g of x is 3, rather, whoops, up here. It never actually happens on our interval. And so we have no critical points. We just basically test the endpoints. And 0, 0 is our starting point. Don't you set f prime of x equals 0? Yeah, that's what this is. But the point is the critical point never happens because g of x is never 3 on negative 4 to 3. So it's actually irrelevant. G of x equals negative 3 here at the endpoint. So that is our max. Basically, the critical points don't actually matter on this interval. So you find them, but it doesn't give you anything useful. So the endpoints are what you play here. And 0, 0 is just a free point. I didn't test it for any real reasons. Okay. Then it says find the limit from the left and right of 0 for g prime of x. So g prime is just the slope of g. So you just find the slope of these lines. So this is really easy. Negative 1/2 here. And here, hairier, like not as kind. It's exactly like straight up and down because it's a semicircle. And so it's actually undefined from the right side. Wait, so is 3 the max? X equals 3 is the max. Yes. X equals 3 is the max. And it's the max value. I guess it just asks for the x value. X equals 3 would be the max value. And it was because 9 minus 9 pi over 4 is bigger than 0, so. And bigger than negative 4. It was the biggest value of any of the endpoints or critical points, of which there were no critical points meaningful on the interval. So yeah, to answer here, it's undefined and negative 1/2. So g prime is the derivative of g. It was just the slope of the graph. And our last one says, find the limit as x approaches negative 2 of f of x plus 7 over e to the 3x plus 6 minus 1. So I'm going to figure out all those other values first. You get e to the 0 minus 1. Oh, that's 0. And you get f of negative 2 plus 7. Well, let's go figure out f of negative 2. F of negative 2 is negative 6 plus the integral from 0 to negative 2 of g of t. There we go. dt. And from 0 to negative 2, we are, well, I should swap the bounds if I want to be going from left to right, negative 2 to 0, and put a negative in front. And so I'm subtracting the area of the shape, which is 1. So it's just negative 6 minus 1. I was being really lazy here, sorry. And saying the integral from negative 2 to 0 of g of t is just positive 1. And we have to subtract it because I had to swap my bound order. And so, sure enough, it's negative 7. And so this is 0 over 0. Negative 7 plus 7 over 0. And so this is L'Hopital's again. So what I'm going to do is I'm just going to say f prime of negative 2 over e to the 3x plus 6 times 3. And plug in, I did plug in negative 2 rather. So it's just 3 on the bottom if you plug that in. So all I have to do is figure out f prime of negative 2 and put it over 3. So f prime of negative 2 is 3 plus g of negative 2. G of negative 2 is 1, so it's 3 plus 1, which is 4. And so that's f of negative 2. So it's 4 over 3, which is our final answer. So sorry about warping around. My stuff was on a different page. But notice how this form of this question was very similar to one off the mock test. It's because these are really good practice questions. They're questions that, like, you can't type in this question into an equation solver and have it do it for you. And that's why these are really, really likely to be on the AP tests, these types of questions. So just be prepared for that sort of thing. They're going to give you questions where a calculator isn't very useful because they don't want you to be getting an advantage. They like no calculator questions. can I make this show up nicely? That's my challenge now. I think so. Ugh. I heard that answers can just be left in the plugged-in form for the AP tests. Is that true? If by plugged-in form you mean you can just write the integral and not actually solve it, that is absolutely incorrect. This test, I would err away from that idea in most cases because it's open calculator everything. The reason why we talk about the answers can just be left in plugged-in form is because most of the AP tests used to be, up until this year, no calculator. So while that is true, it is not as likely this year that you're going to want to do stuff like that because you get a calculator. Do you think those integral limit questions are going to be on the test? No, I think it's pretty unlikely that those will be on the test. However, they could be. So, I don't know. Do you think the test will be more complicated? No, I think it will be more abstract. So, like, that previous question was really abstract. Like, looking at your notes was not terribly useful for a lot of that question. It was mostly kind of deciphering and pulling out the parts and actually figuring out what f prime is and all that kind of stuff. And so those sort of questions are way more likely, in my opinion, than questions that are more kind of rote algebra-y. So more abstract instead of more complicated is my thought. So I would like you... Dang it, did I put it off the page? Sorry. I realize I put the question off. You could probably kind of read it, but now it's fixed. So I'd like you to try this guy out. Implicit differentiation is actually one of those things that could very much be on the AP tests because it's another thing that's really hard for calculators to do. You can find implicit differentiation calculators like Wolfram Alpha, but showing your work to do that, that's a little bit more like you have to pay for the extra features in Wolfram Alpha. And I bet if you copy Wolfram Alpha, they disqualify your AP test score. So maybe I wouldn't do that. And I realize D is like crazy small, so if you don't actually end up getting the D, that's okay. And I'm going to try to figure out why the scoring guidelines are showing up so crappily. I swear I put that on my Google Drive. And click the share link. Share. Oh my gosh, because it was restricted. That's very frustrating. They keep changing the settings on Google Drive. So I will fix Teams now. So the link works. And that one works. Sick. All right. And if you're saying done and I'm not acknowledging, sorry, I'm fixing the Teams link so people can look at solutions if they want to look at more solutions from the last homework. I posted the solution guides on all the teams for all the classes. Implicit differentiation is gravy now. Yeah, I agree. Once you've done a bunch of like related rates and that sort of thing, or even differential equations, you just every one of those steps makes you better at this sort of thing. Uh, it's one of the cool things about calculus. It's so sequential. Like everything you do makes you better at everything you've done, which is really cool. It's what's so exciting about it to me. It's like it's one of the kind of underwhelming things about teaching geometry is the things don't like flow together as well. Or even something like algebra 2 or uh, algebra 1's actually pretty great for that. Algebra 1 might be the number one class before calculus that you took that was that sequential, where everything you learned in the year required you to know the previous unit somewhat, which is an interesting thought. We haven't done any maximization FRQs. We actually have, Liam. Uh, so you, they do a good job of veiling it, but the previous question we did, B was actually exactly that. So um, it doesn't feel like that, but it is a word problem where you're finding a maximum, which means it's exactly an optimization kind of question. So, um, yeah, they look they have a wide variety of looks. They don't all look like the ones that we maybe did in class or that sort of thing. Doop doop doo doo doop boo. So this question has some more involved later parts because x and y both matter, which is a little not gravy in some ways. Uh, so if you're struggling, that's the play. Is for any x value you know, you got to know the y value there too. So there's some interplay between those. Optimization was the heartbreak of first semester. Oh. Yeah, I'm wondering if I should change my optimization unit a little bit to. But man, it's so hard to do so many of those questions that optimization is used for without knowing integrals. That's one of the problems with teaching calculus is everything wants everything else uh, all the time, and that makes things a little trickier. Like I couldn't have given the question B from the previous part without knowing how to do all of the different pieces, which is a little heavy. Um, Done, except for D. Oops, I didn't see that. Yeah, that's fine. If you can't read it like you're reading on a tablet or something like that, like I totally understand. I'm gonna zoom in on it when we get to it. Uh, and I'm probably gonna start in like a minute or so. So let me know when you're there, and I will start. Do do do. I'm kind of thinking it's okay for me to do A without talking through it, so I might just start mobbing it so people can just check their work. Man, hopefully you didn't follow in my footsteps. My way did not make this question easier. Because I had to multiply that factor at the end to get to the answer. All right, any qualms about A before I start mobbing B and C? Doesn't look like it. So folks, if you're trying to find a tangent line, first thing you need is a derivative equation, but second thing you need is both the x and y points, because our derivative equation has both x and y. So you have to plug 6 into your original function. So 2 times 36 is 72, plus 3y squared, minus 24 times y equals 36. And you actually have to solve this equation, which requires you to actually factor or do the quadratic formula. So you have to get it equal to 0. You have to take out a 3. Well, that's the smart play, not to do the quadratic formula at this step, because this does factor nicely. And get the 2 points. So you may notice the question says, at each point on the curve where x equals 6. There are 2 points on the curve where x equals 6. There is, and this isn't C I'm doing, 6 comma 2. Dang it. 6 comma 2 and 6 comma 6. Let's see. Why did you have to multiply it by the factor in 8? Because I needed to match to their answer. Raquel, this answer's fine. Like, this isn't wrong, but it's wrong for this problem because I need to show that it equals what they say it equals. And that's why I needed to multiply by that factor, which is just multiplying by 1, but changes it to look like the answer they want me to get. So now that I have the 2 points that my graph goes through, now I can figure out the slope at each of these points. At 6 comma 2, my slope is 4 minus 12 over 18 minus 4, which is negative 8 over 14. And if I plug in 6 comma 6, I get 0 over 6. Well, that was actually a lot easier than the first one. So the slope is 0 at 6, 6, and it's negative 8/14 at 6 comma. Dang it, did I mess that up? I did mess that up. It's not negative 6/14. I swapped y and x like a scrub. Okay, so it's actually 6 minus 12, so it's actually negative 8 over negative 6, which is 4/3. So it's actually 4/3 is a slope and 0. So we need to put our ID and initials at the top of notes. Yes, yes you do. And it will give you directions to do that, for sure. So anyways, I have 2 slopes here. Now I just need to find the tangent lines. So it's y, okay, if the slope is 0, it's y equals 6. That's one of our equations. Wait, find the slope of the line at the tangent. Oh, okay, I didn't actually need to find the tangent line equations. The 2 slopes are 0 and 4/3. Done. That's B. All right, moving on. Oopsies. Find the positive value at x, of x for which the curve has a vertical tangent line. So for a vertical tangent line, what we want is undefined slope. So what I want for C is I want where 3y equals 2x. Okay, so I need to figure out where this happens. So what I'm gonna do is I'm gonna basically convert one of my starting equation with this ratio. That 3y needs to equal 2x for me to get a vertical tangent. So what should I plug in? For 2x, plug in a 3y, or for 3y, plug in a 2x. Since I'm looking for an x value, I should probably replace all the y's with 3y's with 2x. Or rather, replace all the y's with 2/3 x. Is the same thing. So I plug all those in, and I get 2x squared plus 3 times 2/3 x squared minus 4x times 2/3 x. And these values should give me the spots where I have a vertical tangent line. And I'll pick the positive one for my answer for this. So if I do that, if I distribute all this crap, I get 2x squared plus 8/3 x squared minus 8/3 x squared. Oh, it turns out this got a lot simpler here, didn't it? Oh, I goofed. This is 8/9. I forgot to square the 3. That makes things better, actually. Okay, so the nice part is all of these are x squared terms, which makes this actually doable by hand. It would be really, really hard without. So if I do this that way, I get 2x squared plus 8/9 x squared, and then I converted this to be like 24/9 x squared. Whoops, that's a minus. And 8 minus 24 is negative 16, and this is 18/9 minus 16/9 times x squared. So it's 2/9 times x squared equals 0. And it looks like my result is that it happens at x equals 0, so I'm struggling to find this critical point. Dun dun dun. Find the positive value of x where the curve has a vertical tangent line. Can anybody enlighten me as to what I goofed here? I'm actually mystified. And that's not a good place to be. It's not 8/9, it's 12/9. Oh my gosh. You right. But does that help me? Not really. Does it? Maybe. Oh! Yeah, that's because I'm an actual stupid person. This equals 36. Oh my gosh. This is what happens when I overheat because my room is like 85 degrees. Is that, yes, thank you, all of the corrections. 12 minus 24 is indeed negative 12. It should be equal to 36 and not 0, so I don't know what the heck I was doing. And you get 6/9 x squared equals 36. If you multiply both sides by 1.5, you get 54 equals x squared. So x equals the square root of 54, and that's my value of x. Lord of Goshen. So, if you're confused as to that process because I got lost in there, here's what's up. You got to make the bottom equal to 0, and that happens when y equals 2/3 x. You go into the equation, and you replace all the y's with 2/3 x's. Then, it doesn't equal 0. These were actually wrong because the original equation equals 36, and I was being a scrub. And so if you just look for where that side equals 36, which you can pretty easily do by just doing some algebra, they're all x squared terms, you can find that value pretty nicely. So notice how that question was not a question a calculator was super useful for. It's actually why I chose these, and my brain is super on point today. So I've struggled some. All right. the bottom one says, let x and y be functions of time such that blah, the same equation. And this is our boy related rates coming back in full form. Because instead of just having a normal implicit differentiation question here, we have a related rates question because both y and x are changing with respect to time. So if I take the derivative of this, I get 2x dx dt plus 6y dy dt minus 4y dx dt plus, or minus, whoops, minus 4x dy dt equals, and now I get what I wanted this whole time and was goofing up, I get equals 0 because the derivative of 36 is 0. And now you can just plug in everything you know in the question, which is actually basically everything. You know x is 2, you know y is -2, you know dy dt is 4, you know you're just looking for dx dt. So you know everything but the one thing you're trying to solve for. So you just plug in everything and you're mad chillin' on this one. Minus 12. Minus plus 8. Dx dt is the thing I don't know. And minus 8. And dy dt is 4. And then you just solve this equation and you get to the answer, to the happy land. -32, -48, that's -80 equals, or -12 dx dt minus 80 equals 0, and pretty easy to solve for dx dt. It's 80 over 12, or what is that, 20/3? 6 2/3? And chillin'. So D was actually, the related rates question might have been the easiest at bat on this entire thing. A was probably the easiest, but this was like maybe the second easiest question on here. Weirdly. I don't have massive brain. I derped like crazy. These were hard questions, and I picked them because they were hard, but then I still derped. So hopefully this was helpful. I know I went over the time, so we lost people to other classes. The one thing I wanted to ask the people remaining, well, so first thing, I want to highlight a couple things here at the end. I want to highlight that on Teams, I now put an update link that actually works for the scoring guide. Apparently they updated the sharing, so I have to do that. But anyways, we have the mock test solutions are all on here via links, and the scoring guide for that last homework, so you can spend a lot of time looking over and grade your own work if you did like maybe 5 of the questions or 3 of the questions or whatever, and I didn't go over them during this live stream. So that's a useful resource. And the other thing is, I highly recommend just slamming free responses. Drew talked about how I did a crap ton of free responses, and that's like a really good play. I really, I was thinking about doing like a nightcap stream tonight where people can just ask me questions. I won't like prepare anything, but if you like are mobbing things and you have questions, I can just be online and I can like play video games until there are questions or something. I don't know. So, what's the strat until 10:30 a.m. tomorrow? The strat is to make sure you have your code, get a lot of sleep, really get a lot of sleep. Holy smokes. Will we have slope fields on our exam? Maybe. Decently likely. Can we email you questions to do? Yes. You can email me questions. So, folks, if I do like a nightcap tonight, is like a 7 p.m. nightcap good? So this is a no prep for me, but I will do questions or answer things for you. Yeah, honestly, Jonah, making sure you get sleep, like, I don't know if you've looked at the studies, but every 2 hours of sleep, I believe, is the standard deviation of IQ loss. So if you get 6 hours of sleep, you're about a standard deviation stupider, which is a crap ton if you've taken statistics. So really, getting sleep is the absolute best thing you can do right now. Like really, really, really. Like A+1 important. Uh, Sleep is for the weak. Yeah, that's what stupid people say, like Elon Musk. Anyways, he's not stupid, but he's stupid when he doesn't sleep, just like everyone else. The reason why a lot of people can get away without sleeping and be high performers is because if you have like a 160 IQ, losing 4 standard deviations still makes you average, so you can not sleep. But that's not a healthy way to live your life. Uh, so, really, really, really get sleep. I'm gonna nightcap at 7 p.m. It's totally optional. If you show up, fantastic. I would love to help you with any studying stuff, and I'll be here. That only pertains to you, Mr. Kennedy. Uh, I don't have that high of an IQ, so yeah, when I get 4 hours of sleep, I'm pretty average. uh, so I should sleep nonstop until. No, I think oversleeping is also not good. Just get 8 or 9 hours. Between 8 and 9 hours would be like you are at your absolute best if you do that. And also make sure you eat. That's the other thing. Like eat and be full for the AP test. So full, well slept, you sleep a lot, and all that is definitely the best. All right. Sorry for all that rambling. I'll see you at 7. If you have any questions, I'm happy to answer anything. And I wish you all the best of luck. And thank you to so many of you who have worked so hard for this. You very much deserve it, those of you who have been like slamming out questions and attending and all that sort of stuff. You guys rock. So, adios.